Okay, the next presentation is development of a mobile robot for inspection of analog gauges in industrial plants. It will be presented by me. It's a work we were doing with our startup and the students from Pontifical Universidad Católica del Perú. I'm from Peru. I didn't want to talk about the development of technology only, but since we have a startup competition, I was thinking that we can provide some of the experience we have back there in Peru and the strategies we are using to develop technology which is based in science and engineering. As you know, Peru is in South America, is a developing country, so the funding we receive from the government is not very big. So first of all, I will present the name of our startup. The name is Tumi Robotics. Basically, we start by developing robots to monitor bodies of water. Autonomous USVs, teleoperated ROVs. When we started to develop this technology inside the university, we were aiming to fishery and aquaculture in our country. However, after we finished the products and we started to do the market research, we didn't find the clients which were able to pay for the technology. Then we pivot, we switched. The mining industry was looking forward to use this type of technology for their environmental monitoring. That's how we started to develop robots to provide services to the mining industry. We founded the startup 3 years ago. During that period, they asked for more technology. They asked if we can monitor their infrastructure, like the pipes or tunnels, which go below the tailed waters they have in order to monitor the infrastructure. We managed to develop the robots with similar technologies we were using for the marine robots, and we started to provide services to them. Then we realized we didn't want to develop technology that for economic purposes only. We were thinking how this technology could be useful for society and the environment, and then we realized that these products not only increase the efficiency and safety of operations of our clients, but if they do these monitorings and inspection more frequently, we could save the lives of the people who work there. We can maintain the environment safe and maintain the infrastructure or capital-intensive investment of our clients safe as well. And this goal is aligned with the Sustainable Development Goal of the United Nations. I think it's the number 9, which is related to infrastructure, innovation, and sustainable economies. This is the timeline of the startup. We started in 2006. We have 3 years already. And during that period, we managed to work directly with 3 of the top mines in Peru. Most of our projects are private funded right now. We received support from the government as well. And we were able to go abroad and being accelerated in places such as Hong Kong, Australia with the MIT Bootcamp, and many other places such as Chile. So we have an interesting experience on how these think about startups and accelerate works. The last year we received funding from the government to develop underground topography autonomous robots. And this year we received a funding to develop a plant monitoring robot, which is related to the topic I'm presenting here. We realized when we were talking with our clients from the mines, they mentioned that it will be interesting for them to have a robot which is able to inspect the plant which shreds the rock of the mining process. When we enter that environment, you have a lot of noise, there is a lot of heat, particles polvo, how do you say that in Spanish? The powder, the particles of powder. And when the people check on the instrument, on the gauges, they do it manually. They do that task manually. And sometimes they write what is best for them, not necessarily what the number really says. So they were asking for a solution in which they automatically measure that data from the instruments and the gauges, and it's reliable. So this is the concept we have with the robot, and we were aiming at, part of the strategy was to develop an MVP in order to develop a final product to be used in the mining industry. So since 2017, we were aiming to this contest. This is the World Robot Summit, in which they have a category, a competition for plant disaster robotics. The task we have to solve there is to prospect, for example, inspect and maintain bombs, motors, open and close valves, monitor the instruments, diagnosis of structures, and response under disaster conditions, for example. This is actually we participated in 2018 on the contest in Tokyo. This is the area in which we work with our prototype, and we're aiming to participate in 2020 in the event which will be held in Fukushima. Well, I think the problem I described it. Usually, most of the monitoring or inspection of this type of infrastructure is performed by human beings. It's estimated that yearly 2 million people die in accidents related to this, and economic losses are in the order of trillions of dollars. The proposed this is our first MVP. The proposed solution is a modular robot, which is a mobile robot with tracks, which has a manipulator arm over it, and develop a graphical user interface based on the specifications we have from our clients in order to make the robot work as they really want. This is the prototype we built. Most of our students are from the mechatronics engineering program, so it was very fast to develop. With the help of some engineers we have on the startup, we gathered some information such as what type of spaces the robot should be able to enter, the weight the robot should have in order to be carried by maybe one people or two people. This is the electronic configuration we developed. It's very simple. It's based right now on Raspberry Pis and maybe Arduino microcontrollers. Right now, we already have the technology to use, for example, the NVIDIA Jetsons in order to apply object recognition with LiDARs. Based on our experience, we select the amount of energy we need for the vehicle in order to work between 2 or 3 hours above 4,000 meters above sea level, which more of our clients are performing their operations. And this is the graphical user interface we use. As you can see, it's very simple. And the idea that it's why we select to detect the values on the instruments first, because when we proposed to our clients to develop a robot to do the task, they didn't believe we can develop that. But they were very interested in developing this type of technology. We can even go with a computer or a tablet and get the data for them. So we get some finance for them in order to develop this type of image processing. What we use is computer vision algorithms, for example, huge transformations to detect the shape of the circles. The region of interest is obtained, and we crop the results around the circle. Then we use canny detectors to extract edges and reduce noise. And this is some of the processing we obtain. Then we use another huge transform in order to detect the center of the gouge. The slope angle of the maximum and minimum value is estimated, and we can obtain the value of the gouge. We test the prototype first in our laboratories. We have with the group of the master of control of our laboratory, we have a small plant simulator with those instruments. We test the robot over there. We make the robot go through some obstacles in order to test the reliability. And we have some interesting results with the vision algorithm we have. It has an accuracy of 99%. It's very fast. It's less than half of a second in order to detect the value of the gouge, even with different lightings and different positions. As a result from this first test, the vision algorithm can measure circular pointer type analog gouge. The error is less than 1% and the response time is below 1 second. The capability demonstrated here is useful for a variety of industries, not only the mining industry. We are talking with the hydroelectric industries as well. And the robot definitely can minimize the probability of accidents due to remote visual inspections and measurement. You have to consider that on this type of industry, to send some engineer over there is very expensive for them. So the idea is they can use these robots in a teleoperated mode first. The future work we have is to participate in the event in Fukushima in 2020, validate the prototype in real environments, as we have top of the 3 mines working with us. They allow us to test the real robot over there. And well, this work was granted not only by the government and the university, but from the startups as well, which, as I mentioned, for a developing country, it's very difficult to find funding. So we strongly believe that these small companies, startups, are the future in Latin America. Thank you very much. If you have any questions.
Hi. I just have a question about your team. So are you mainly engineers at this point, like your startup team, or do you have a good blend of people with business backgrounds, or did you have to pick that all up on the way through this competition?
Yes, we started with engineers. The last 3 years I was involved with management of innovation, but I'm looking forward to get more people related to the business side, because it's very difficult for our engineers, which are quite young, their soft skills, their communications, they are not well developed. I think with age, you become an expert on that, like me. I think these people from the mining industry, they believe in me. But it's good that when you build a startup, you work together with someone from the business side. It's very important to have a very good business plan in order for survive through all the process of trying to grow your startup.
Thank you.
And you need lawyers as well.
I'm just wondering, I don't know, maybe I missed it, but how does the robot does it navigate autonomously throughout the plant?
No, it's not autonomous now. Oh. It's teleoperated.
Okay.
We will start some tests in order for our students for the master program to publish some papers to try the autonomous mode with the LiDAR sensors or the real sense cameras. But in order to develop a product which is working already in the mines for next year, we are aiming only for teleoperation right now.
Thanks.
Good presentation. Another interest I have is, do you have, with your robotic apparatus, a site map? Anything that do you know, or does the robot operate with some knowledge of what it's going into and what it should expect? And also, if it finds something that is not expected on its site map, what would happen?
Mm-hmm. Yes, we will ask the clients to provide the map of the plant. The idea is to give the robot at least a semi-autonomous performance, like in which if the teleoperator is saying go ahead, but you have a beam or a people in front of it, the robot don't move. We didn't implement that feature yet, but it's necessary. And we know that even if the company give us the map of the plant, every time we went there to provide services to them, the plant never matched with reality. So we definitely need that feature in the future.
What would you anticipate would be best to adapt to these unexpected events or observations?
Sorry, I didn't understand.
How would you adapt to things that you weren't expecting?
I think we have to test the the device for at least for 1 year with one of those companies in order to realize which are the real problems and try to solve the problems, not only with code but with the hardware. And we have to figure it out. As a startup, we don't think too much on every detail. We try the robot to have the basic features which will make happy our client, and they know that. For example, with the other robots, it was many tests until we get the information they want. Maybe 4 or 5 tests, but on those cases we provide only a service. Which, for example, we went through one pipe, which looks like a simple task, but it is very difficult. For this type of product, we need to stay with them at least 1 year working there.
What kind of communication are you using? You said that in the mining, when you do it in the mining, you'll be teleoperating it. But using a Bluetooth or Wi-Fi in a mining scenario.
Yeah, no. For the plant, we can install Wi-Fi. It's very simple.
For the mining.
For underground,
yeah,
we are trying. For example, the project I show you, the underground robot. The task which will provide money for the industry is not the autonomous robot, but only when they blow the front. Okay, you have to measure the volume of the front. So you can use a tethered robot. The thing is that they don't want the people to enter the hole when they blow it because there is a risk of rocks falling. So there are some people who died already, or maybe the $100,000 LiDAR crash with the rock, so they want to avoid those risks with the robot or expensive LiDAR systems. So it could be tethered now. But we're not trying to solve the DARPA contest like the autonomous robot and the underground tool. Thank you very much.